We leave about the top half blank. Okay, number 2, we're going to write it maybe a little bit as we go. We'll keep most of it the same. There's a little bit that I wrote a little different in my other classes that went kind of different, so we'll kind of maybe notate it a bit. All right, so number 2, our goal is to factor this. So we want to write it as 2 binomials is our goal. First step to do is notice it is a quadratic. So a quadratic has 3 specific parts. Who remembers what do we call this 6? Which coefficient is that? A. Negative 17 is B. And 12 is C. Alright, yesterday we used green for A, so I'm going to keep just using the same color as I did yesterday. I used orange for B. And I used blue for C. Alright, then we like to use our area model. Adrian, take out your notes, dude. Do them with us. You goof. Alright, so I'm going with my area model. How many boxes do I make in my area model? 4, which is why I like to think that it's called a quadratic, because a quadratic is 4, but this is really a trinomial. It's only 3 parts. So in our area model, there's 2 spots that I can fill in right away. C and A. Where is the A going to go? The very first box. I'm going to put in that whole 6p squared. And where is our C going to go? The last box, 12. Now what happens with our B is we have to split that B up into 2 parts, that negative 17. It's going to go in 2 different boxes, but we can't put negative 17 and negative 17. We have to figure out what to split them up into. Either way, we know both of those terms are going to have what variable with them? A P. So I'm going to just at least put a P and a P. Now to figure that out, we follow this pattern. We do our A times our C. So which number, or which coefficient was our A? 6. And we're just going to take the coefficient, so just the number 6, times our C. What is our C? Okay, again, if you want to color code, you can. At this point, I still really like to color code. At some point, it gets a little excessive, but this part I like to do still. Alright, if we're not sure, we can always use Desmos to help us through that. So 6 times 12, we get 72. Now, based on that equation, we're going to write 2 more equations. We're going to write a multiplying equation and we're going to write an adding equation. For my multiplying equation, we're going to drop down that number we just found. That's 72. You're going to see this arrow on your worksheet today that shows you to drop it down. But for the adding, when I combine these 2 boxes, which one was it supposed to be equal to when I put them together? Not the C, the B. We want this to equal B. And what is our B? Negative 17. Again, this is the part I still like to color code. After this, some people think I'm excessive with the red and the purple, and that's fine. You don't have to do it if you don't want to. All right, so what we need to do is we need to find a number that when I multiply the two numbers, I get 72, but when I add the numbers, I get negative 17. So I'm seeing a lot of people already grab their blue sheet, which is great. On the blue sheet, should we look at 72? 17. Good. 72, because that's the multiplying problem. So in that 72, I'm looking at all these pairs. And I'm going to think adding first with these pairs. So I'm going to think, does 1 plus 72, does that equal 17? Okay, what about 2 plus 36? What about 3 plus 24? If we're not sure, we can grab our Desmos. 3 plus 24, does that equal 17? No. Okay, 4 plus 21. We'll get there, I promise. Okay, what about 6 plus, where are we? 6 plus 12? Where, what? 72. It was supposed to be not 4 plus 21, 4 plus 18, sorry. 4 plus 18, is that 17? Nope. 6 plus 12? That's really close. A lot of you already said this. 8 plus 9, is that 17? Yeah, but I want it, do I want it to equal 17? Negative 8 and negative 9 would make negative 17 if we make them both negative. Does that work for the top one? Yes. Does the negative equal a positive? Yep. So those are the two numbers we're going to translate into our area model here. Okay, again, if you don't want to do this part, this is the part that gets a little excessive. I'm going to take this negative 8, and I'm going to throw it here. And then our negative 9, that goes here. Now, I could have flipped that negative 8 and that negative 9 around. Our answers would have maybe looked a little different, but our final answer would be the same. Our work would maybe look a little different. All right, we're about 2/3 of the way through this problem. We have 1/3 left. I think this is the hardest part. We've already done it. Now at this point, we are going to factor it. Okay, you had a pass? Awesome. All right, so we're going to start with either a row or a column. It doesn't matter. So do you want to start with 6 and negative 9, negative 8 and 12, 6 and negative 8, or negative 9 and 12? 6 and negative 9? Okay, if I look at 6 and 9, I want to look for the greatest common factor. So in 6 and 9, what is the biggest number that is in both of those boxes? 3. All right, now as I look across, what else do they both have? A P. And I want to put that in front of where I factored that, 6 and negative 9. Now, we can either continue to find greatest common factor, or we can think about it as a multiplying problem. So for the 6, I can think 3 times what gives me 6? 3 times 2. Do I need another p to get a p squared? Yep. 3 times what would give me a negative 9? Negative 3. Okay, now I need one more down here. 2 times what would give me negative 8? Negative 4. Do I need another p here? No, and if I'm not sure, I can look across. Do both of them have a p? Nope. But what's really nice is we have a fourth box. We can just double check our work. Does negative 3 times negative 4, does that make a positive 12? Yep, so that should be the right answer. All right, when we write our answer in binomials that we're multiplying, it doesn't matter which one goes where, but what matters is what we keep it together with. So if I start with 2p, what's going to go with my 2p? The negative 3. Those go together. So I can either write it as a minus 3, or I could write it as plus negative 3. And what's my second binomial? 3p minus 4, or plus negative 4. We keep these ones together then. And that's our final answer. If you wanted to, or if you wrote it differently, you could have done 3p minus 4 t plus negative 3. You could have flip-flopped those around.